Hello friends, in today's question, a mass m is undergoing SHM in a vertical direction about a mean position y0 with amplitude a and angular frequency omega. At a distance y from the mean position, the mass detaches from the spring. Assume that the spring contracts and does not obstruct the motion of m. Find the distance y measured from the mean position such that the height h attained by block is maximum. So we are given this in figure. We have spring and mass, and it is said that it is about the mean position is y0. So let me draw it again. So this is the mean position, which is given as y0, and we have this is a mass m, and its amplitude is given as a, so it means in maximum side as well as in the minimum side this will be plus a and this will be over minus a. And it says that detaches from the spring, so let us assume that the mass is detached. So this is the mean position and mass is detached somewhere here, and its height is given from the mean position, or distance from the mean position is given as y, and we have to find out the distance y such that the height h attained from the block is maximum. So this height attained by the block is our maximum, this which we are supposed to find out. Let us suppose this is the height that is being attained, and the point where the, you can say, block is detached from the spring, it is going to have a velocity v in this direction, and we already know the formula for the velocity v, and at a distance y from the mean position. So let us call this as point D. That's the point of detachment. You can say velocity at point of detachment, velocity at point of detachment, that is point D. So means as soon as this mass m is detached from the spring, it will continue to move in upward direction with the velocity v. Okay. So therefore, you can write it like this: when the mass m detaches itself from the spring, at a position D, which is y distance from the mean position, it will continue to move upward. It will continue to move upward with the velocity v, with a velocity v, and this v velocity is given as omega square root of a square minus y square. And let's find out what will be the height achieved by the mass after the detachment. height h achieved by the mass m after detachment. So let's draw a figure once again. So this was our point of detachment. Here is a mass m. It is moving with a velocity v and it travels a height of h, and at this point the velocity of the mass will be 0. Okay, for the maximum height, for the fraction of a second before it is going to return back, its velocity will be equal to 0. So we can use the equation for kinematics. So we can say that once the mass m detaches, it undergoes free motion. It undergoes free motion under gravity. Therefore, we can use equation of kinematics, and which gives us that using equation of kinematics, v square minus u square is equal to 2as, where v is the final velocity which is equal to 0 and u is equal to v. So this becomes our v square, and we have a is equal to minus of g. This is minus 2g and distance traveled is h. So minus and minus goes away. So we can write, and we know we know is our omega square root of a square minus y square whole square is equal to 2gh. From here we can find out our h. H will be equal to omega square a square minus y square divided by 2g. So the total height h, let us suppose the total height is given as capital H. So this is the total height from the mean position, that is capital H. Capital H will be equal to small h plus y. Same thing we can show here also. I forgot to mention here y. So this is our y. So total height is our capital H. So capital H will be equal to h plus small y. Small h plus y. So you can say total height from mean position, which is capital H plus small y, and we substitute value of h, we get y. This is our y square 2g, and we have a square minus y square, and we are supposed to find out that the height attained is maximum. So we can maximize it by using, we can find out its value by, if it is maximum then its derivative should be equal to 0. We can say max for maximum height dh upon dy should be equal to 0. So we derive this equation, we get 1 plus omega square 2g, and this becomes 0 minus 2y is equal to 0, and this can be written as minus 2y omega square 2g is equal to -1. Minus and minus goes away, 2 and 2 cancels, we get our y is equal to g upon omega square. So this is given as the distance from the mean position. This is the distance from the mean position. And in the question there is given one condition that a omega square is greater than g. Okay, so let me write it first of all here. We are given that a omega square is greater than g, where a is the amplitude. So from here I can say a is greater than omega square upon g, and my mistake. So y is equal to, one second, yeah, this is correct, g upon omega square. Sorry, there was a confusion on my part. So we are given a omega square is greater than g, and from here we can say, okay, so I wrote this part wrong. So this gives us a is greater than g upon omega square, or we can say a is greater than y. So you can say the amplitude is greater than the point of detachment. Okay. So this is the only condition to make sure that the point of detachment is within the maximum and minimum amplitude, where a is the amplitude of motion. This is the only condition. So based on the given result, we can easily verify that this condition is true. So that's the only reason for giving the condition that a omega square is greater than g. So this completes the question. Thank you.